Good morning, good afternoon from wherever you guys are watching this webinar. Thank you for joining us today. Today we're presenting a building an AI product from problem discovery to MVP, and I'd like to bring in today's speakers. Today we have Cassandra and Jordy. Hey Jordy, hey Cassandra. Thank you guys
Hello.
for joining us today. We also have our colleague Evan in the background, so if you have any questions, submit them and he'll help fill that for us throughout today's presentation. But before we get started, just a few housekeeping items. We'd love to keep this as interactive as possible, so if you have any questions for us, please submit them using the Ask the Questions tab below, and we'll do our best to answer all of your questions live today. And I know that you guys are here to hear from us, but we'd love to hear from you. So if you have any feedback, hit the Rate This tab also below the presentation screen. Let us know how we did, how we're doing, or you'd like to hear future events by leaving us feedback. Without further ado, I'll hand this off to today's speakers. Team?
All right. Good morning, good afternoon, everybody. So we'll be talking about building an AI product from problem discovery to MVP. We'll go through some introductions, some top takeaways, our goal, and we'll really then get into some foundational capabilities and product development practices for operating within this space. We'll then transition over where Jordy will get a chance to talk about putting that toolkit into action, talking about her time with working on the Karina project. And then we'll wrap up with some post MVP notes when it comes to managing an AI product. Okay, so hi everybody, I'm Cassandra. I'm a senior product manager at Tanzu Labs, VMware. I have a background as a machine learning project manager at Meta and currently completed a certificate recently with MIT on designing and building an AI product.
Hi everyone, I'm Jordy Ensign. I'm the software engineering manager at Tanzu Labs Public Sector. Previous to my VMware tenure, I spent a great deal of time in the engineering space for simulation and modeling, gaining its training in the public sector as well. So we'd like to kick off this with a little bit of a teaser for one of the case studies we wanted to share later on in the presentation. Karina is an innovative technology nonprofit serving at-risk individuals, specifically care seekers looking to engage with care providers within the U.S. healthcare system. There's a great potential in edge technology like AI, ML to serve this group of people, and Karina was interested in exploring it in support of the mission of connecting people. Partnering with VMware over a 3-week timeframe allowed them and us to go fast with a very quick speed to value application that leveraged Spring and Spring AI. That's a project that was developed internally that we'll talk about a little later. We spent the first couple of weeks getting to know the Karina team and their company mission, exploring technical problem spaces that Karina is currently experiencing in order to identify the right use case to tackle. Together with Karina staff, we started sketching out what the rest of our tech stack and implementation should look like. And by the beginning of the second week, we had an application running. We're actively testing it in a local sandbox. We had added some integral features, and we were iterating on what done should look like when the engagement ended. And that did sort of change over the course of 1 to 2 weeks, believe it or not. That was last week, by the way. This is how fresh this use case is. As we approach the end of the engagement this week, we started to reflect on discoveries we made together, technical, ethical, legal, and financial, and what we can do to make sure that Karina can continue forward with confidence exploring this solution. And while that application might have been the sole MVP to come out of this experience, there's additionally a great deal of value in the partnership VMware established with Karina by helping them to find the right tools and information to make good decisions for themselves in this space.
All right. And so we'll get a chance to unpack that case study thoroughly and then get into a little bit more details at the end. So just to center us in our goal for today, our goal really is to empower teams to build highly valuable AI products. Our strategy is to demystify the process from research to technical design to launch considerations. And we'll show you how to specifically use user-centered design approaches, technical design approaches like the data science hierarchy of needs, and a launch checklist that accounts for ethical considerations. This will all be within agile and lean product development. So with that, we'll go ahead and start talking about AI capabilities. So from a foundational perspective, there are 4 different capabilities associated that AI can perform. So the first is analyze. So we're thinking here of the ability for an AI product to analyze data, predicting a simple output. For example, predicting a flight price to Cancun for next May. Second, we're thinking about AI products that can sense. So sensing language, sensing images, sensing videos. In my time at Facebook, we used a lot of products to detect misinformation. So sensing a lot of the captions in posts, images, videos, and the like. And third, generate. So we're thinking here about a lot of the conversation right now with Gen AI, creating a lot of those complex outputs. Generating a business headshot, for example. There's a really cool app I saw recently where you can provide a few different photos of yourself and it'll generate a net new headshot for whatever purposes you need for business purposes. And finally, a lot of products out there are within this sort of acting space. So AI products can be used to act using robotic hardware. You can imagine catching a self-driving car while you're out on the town. And so a big sort of kind of principle we're going to be talking about today is complexity and operating at high impact without having to go high complexity. And so we'll come back to this, but essentially just note that we're thinking of complexity from that analytical capability all the way down to act with less complexity to increasing complexity. So to get a little bit more technical, what we're talking about here is at the lower end of complexity, we're talking about a lot of the more traditional machine learning styles of supervised machine learning and unsupervised machine learning. And increasing complexity, we're talking about deep learning. So within that, natural language processing, speech and computer vision. And then on the generating side, still within deep learning, we have GANs, general adversarial networks. And then when we're going into the final phase here of ACT, this is evolved methods involving multiple layers, not only of software, but hardware. Okay, so now that we have a sense of capabilities, we're going to talk a little bit about product development within the space. So whenever you are operating within this space, we like to use the double diamond for the research and design phase at Tanzu Labs. So when we're talking about this research section in the blue on the left, this is an opportunity and a time at the beginning of your project to externalize problems from the users, prioritize those user problems, and then give an impact and effort, rank them in order of priority. And then you'll really want to focus a scope on the top problem. So moving into that design phase after you do your research, you'll want to develop potential solutions. Then you'll prioritize those solutions based on user impact and technical effort. So let's kind of get a little bit more detail into what we're talking about here, potential solutions. And let's bring in a little bit of technical design here. So when we're talking about identifying potential solutions within the design phase, we're talking about designing the UI and as well as designing the AI. So when we're thinking about designing the UI, we're talking about designing the wireframes of these potential user-facing solutions that may meaningfully address these user needs. But more importantly, we're also talking about designing the AI. So you're going to be designing outlines of these potential AI products that would power the UI. So a key question to ask yourself in this moment when you're working with your team in this space is, will you be using an existing model or will you be creating your own? So, for example, on the left here, you'll see using an existing model. You might be picking one from a public library. Then you'll be selecting a sample data. You'll be making a prediction using that model, and then ultimately testing and showing value to see if this is a good fit for your team. This is a really fantastic place for teams to stay in, using an existing model out there. But if you have, a little bit more robust resources and investment, you are more, of course, more than welcome, better position to actually build your own model. So building a simple model, that might look like, picking one, sort of refitting it, giving your data set and your context. But essentially, this might be in the more supervised learning space, in the more simple model types. This third section is all about building a more complex model. So if you have, well-staffed research scientists on your team, you can actually get into more research spaces and start building more complex models. And so when we're thinking about the vast taxonomy of AI products, up in the right, the top right here in this red box is a lot of the more simple kind of models. It's very much a high impact space. So working within supervised learning, unsupervised, and within the machine learning space is a really fantastic place to start. The reason why we're saying this is because there's a tremendous lot of conversation on Gen AI and working with general adversarial networks to build generative products. That's great, but that is not the only way that your team can have impact within AI and develop within AI. There's a tremendous amount of prediction work that you can do within machine learning spaces with far less investment, far less investment. Okay, so coming back to our double diamond, we talked about potential solutions and how we want to design the UI and design the AI. We want to look closer at designing the AI here. There's a second tool I really want to share with y'all, and it's called the Data Science Hierarchy of Needs. And it's really fantastic to help develop a comprehensive technical design. And so what you want to do is use this pyramid with your team and have a technical design discussion. And all this does is ensure that you're comprehensive in your analysis. It's not prescriptive on the right answer. It just encourages comprehensive conversation. So you want to understand your data collection strategy at that bottom layer. You'll progress to understand your data storage strategy, and then progress further up into the pyramid of understanding what it is you're going to be doing in terms of transforming that data, labeling the data, and then ultimately picking an algorithm and experimenting, and ultimately picking learning that the patterns in the data. Okay, so we talked about potential solutions here in designing. We're going to move forward and think about testing. So let's say you've designed some great solutions, you've prioritized based on impact and complexity, you're ready to start narrowing down and start testing a few of your top choices. And so I really want to highlight here, it's incredibly important that as you do work in a more technical space, don't forget to bring in your product designers. You really want to make sure you're testing the UI as much as you're testing that AI. And so they work in parallel. You'll be testing the UI by creating a prototype and test with users. You just really want to ensure you're building a product that meets the user needs. In parallel, testing the AI. So creating a prototype. At this point, it's a really good time to validate desirability with the users, viability for the business, if the business is ready to put some money into development, and the feasibility of the output of the AI. And so that is going to be a really nice conversation you're going to have with your team, and specifically the engineering bench, to ensure that whatever it is this prototype is projecting out to be, you're set up to build and manage and maintain and ensure reliability of this product. And so just to keep it super simple, you simply prototype your AI, and then you're going to want to just run a simple, simple test with your users, double check with your business, and then double check with your team to make sure you guys can maintain it. At this point, I do want to call out, it's a good time to also prototype your software development approach. So what does ML ops look like for your organization? How do you want to manage this product? Do you want to bring in auxiliary support? Do you want to manage it in-house? Do you want to have third-party support? These are conversations you can have with your leadership. And you also want to take this time to identify potential AI cancer risks. These are just potential risks that you might face in the future of your product. So we'll look a little bit closer at testing. So when we're talking about prototyping the AI, we're talking about implementing a model with 60% accuracy. We want to find an MVP here and really start quite small. Find a model that fits your needs and start with a pretty low, moderate accuracy. And then you want to validate desirability. So do users value the type of output that's coming from this model? Maybe they prefer a different type of data. Is the business bought in on the projected resources here and the costs? So you're testing for viability here. And then finally, you're going to want to validate for feasibility. So is this model easy enough to be built and maintained by your team? Is the data likely to be available? And is it generalized enough for the task? I just want to highlight here, there's no right answer for these, but these are just general kind of questions you want to be answering with your team together. When you're prototyping and testing your AI, you want to also identify risks early on. So the first thing is to really make sure that you're ensuring your model is generalized enough. So make sure your model isn't biased towards one type of input. You can imagine if you're building a face recognition software for an iPhone, you want to make sure that it can recognize all faces, not just some. Second, on adversarial attacks, make sure your model is protected against input signal attacks. For example, Siri can be manipulated with sounds that are inaudible to us, right? So you may want to do a little bit of analysis, and you could do a bug bash, you can call it whatever you like, make it a team effort, but really get together and start thinking about potential adversarial attacks. Third, to sample your data and understand if there's some unexpected behavior that might come out of your model. So for example, Gen AI recommending harmful action. The one way to test that is through qualitative testing. So you can sample the data. If it's a representative sample, then you can all look at the outputs and understand if there's anything there that might need to be looked at further. There are also quantitative ways of testing that, and you can work with your data science team to look into that. And then finally, lack of explainability. So if you work within a space and your model is easy to understand, that'll be easier to defend with the public and easier to explain to the public, garnering more trust. If you have lack of explainability of your model and it's a little bit more of a black box, maybe it's a deep neural network and you have a lot of your features are abstracted, that's okay, but you're going to have a lack of explainability, which could be quite unclear to your users, and it could pose a risk to your users' trust and also to your team's ability to troubleshoot. All right, so we talked about designing AI and testing your AI. We're going to want to move over and think about progressing. So we assume the test went well, you've been having the right conversations, we're ready to move forward. What we want to really do is start receiving feedback and working within a lean and agile space. So thinking about having your solution and building it with lean in mind, you want to make sure you're building that prototype, measuring performance, and learning to iterate on the design. And then bringing in agile, you want to deliver small amounts of valuable software consistently using user stories and continuous integration and delivery. This prevents waste, right? If you're delivering small incremental chunks of software, then you're ensuring that you're headed in the right direction and not building, and then delivering down the road when it's too late to have pivoted, given user feedback. All right. So here are some examples. Shout out to Amanda White, who put together these really fantastic examples. But essentially, what we want to do is practice agile and don't shy away from using user stories when you are developing your model. Very much okay to talk to your data scientist, talk to your engineering team, break down the work, and write them into agile user stories. And on the left here, you'll see there's a screenshot of the UI. This really just highlights the importance of testing that UI with, in partnership with your designers, while also testing that output from the model itself. And so you want to make sure you're using lean practices of build, measure, learn early, often, and consistently. Okay, so we talked about what it's like to use an existing model, keeping it simple, all the way to building your own. I want to call out again that there's a lot of value at hand of working within a space where you're using an existing model. And we'll have a chance to have a little bit more of a conversation where Jordy's going to walk through how her and her team use an existing model to support Karina. And with that, I'll hand it to you, Jordy.
Thanks, Cassandra. So given all that Cassandra has shared, let's get into more detail with our case study, Karina. As a reminder, Karina is a technology nonprofit focused on providing an online care matching service. So between VMware and Karina is a balanced team pairing of engineering, product design, and product management for this engagement. This was key for getting a holistic understanding of the technology we're building and its impact on both the company and the end users. We spent the first week learning about Karina, walking through user personas, teaching some of the core AI, ML technical concepts and terminology to the Karina team, so we all had a shared context of both the problem and the potential solutions. In this case, the solution we settled on was to build a chatbot that would allow a user to ask home care related questions that were specific to the state of Washington. Karina currently has 2 avenues of answering a care seeker or care provider's questions, a contact us form and a support line. What they revealed to us was 25% of the support calls in a 10-month time frame seemed to center around things that could be answered within the corpus of an FAQ. So this was an opportunity to build something that could provide users with fast answers, ease the volume of support calls, and demonstrate the power of a large language model. With all this in mind, we got to work. I think it's worth noting too that these images from my source of the presentation have collaborated with ChatGPT 4 and DALL-E. In this case, I asked it to give me an image of a balanced team working together to find a technical solution in a time frame. So this is what ChatGPT gave me back. So that was week 1. By the end of the first week, we had also started to narrow down what our stack would look like. So we were going to use Spring and Spring AI, and that the Spring AI we'll talk about a little bit more. It's something that was developed internally. We needed a way to upload a corpus of text, so that FAQ. So we added a PDF reader to the Spring AI project. And then in order to create embeddings, because we were driving towards RAG, so Retrieval Augmented Generation solution. So the model had additional Karina-specific context to process for its completions. So for the sake of the sandbox testing and speed, we elected to use OpenAI's ChatGPT 3.5 Turbo large language model. So we grabbed a couple of auth keys and we were off to the races. The considerations here to remember were that we only had 3 weeks. There wasn't going to be enough time to train a model and get meaningful results to prove out the solution. And we didn't have a data scientist. So this is why the selection was an existing model. Using ChatGPT, we'd be able to track token usage to inform cost metrics at the end of this engagement. And the data Karina provided was publicly available, so we were not risking PII, PHI, or HIPAA data exposure during the testing. In this image is another ChatGPT generated one where it put together what it considered a joining of Spring, kind of the Spring Leaf logo and OpenAI collaboration here. So in weeks 2 and 3, we initially discussed that a single FAQ might be a really low bar for building a proof of value. And we had stretch goals in the backlog for adding an FAQ for Oregon-specific information or for logging in and account management. But since we were able to stand the application up so quickly within a few days, what we discovered with that single corpus of data, while it was a simple use case on the face of it, was helping us discover a whole host of other considerations, similar to what Cassandra mentioned regarding AI cancer risks. We set up conversations with an ethicist, Clara Berridge, and legal counsel. So there's a number of instances where chatbots in the news, including ChatGPT, are delivering more harm than good. One of the things she suggested was to not name the AI. And we had named the project overall after one of the Karina engineers' cats. So we were inclined to name the chatbot this as well until we had talked to her and had sort of second thoughts. Karina's care seekers are a particularly vulnerable group. If you've ever needed to care for a loved one or a family member, doing so can be incredibly frustrating, stressful, and you can feel really out of your depth trying to navigate doctors, institutions, and pharmacies. You desperately want someone to have answers you don't have, so an AI confidently hallucinating the wrong information can have drastically unwanted results. So this was one of the considerations we had after talking with her, is wanting to make sure that this chatbot solution was going to provide more good than harm, especially for these users. So in exploring that, we realized we have a ton of things to learn just from the single FAQ. So the direction pivoted from adding more data for each data set we were given. What are the right answers? What are the wrong answers? And how can we provide guardrails through prompting or adjusting model temperature to come up with a mean of answers that the model provides that are within acceptance criteria for Karina's risk acceptance, right? So creating this process is something Creata could then templatize going forward as they tested different data sets or different models. So we found the value was more in doing a single use case, run the thread through with the data, see what we can come up with, and then Karina later could templatize that and move forward. And this is ChatGPT giving me an image of what it considers an AI hallucination. I really like this one. So all of that discovery and exploration has been culminating this week. This is literally like we are on the third week this week. We've got good cost usage data for all the test prompting using ChatGPT 3.5 that Karina can use to understand what a monthly spend would look like. And this is given assumed support volume numbers based on what they've seen before and maybe continued accessibility with a chatbot. Maybe the numbers will go higher. And where that cost could tread potentially into the cost of supporting their own model, either internally or leveraging a private model service from offerings like VMware or OpenAI, Private AI. What are the privacy concerns regarding data, and are services like these taking that into account for enterprise solutions? Would there come a time where Karina would want to invest in training their own model? And what are the costs and trade-offs with that solution, including personnel? What information domains is Karina comfortable letting an AI sort out, and where should human intervention step in? The last bullet here is just a reminder, we initially assumed a single FAQ would be easy to prove value, and from a stand it up and get it running fast, we weren't incorrect. But I would absolutely recommend your team start small and take the time to discover and process all the complications that come from playing in this space, because that's really the end result here. The tech is easy, air quotes. The hard part, I think, is understanding the risk, cost, and innovation trade-offs that come with AI ML solutions, and making sure that you and your client are comfortable navigating that space. And this is ChatGPT being very dramatic in that trade-off between risk, cost, and innovation. I'll hand it back to you, Cassandra.
Awesome. So we've talked a lot about the double diamond using user-centered design, and we talked a lot about using an existing model. For example, the Karina model using ChatGPT 3.5. We want to close out with some considerations for teams that are deciding to build their own and not use an existing. And so want to shout out Capgemini here for this awesome graphic, but essentially, on the left side here on the y-axis, you see methods in order of lower complexity to highest. And so as a team is considering building their own, it is encouraged, if this is, especially if it's the first model for an organization, it might be best to start in a lower complexity space of the supervised and unsupervised space, and then progress into maybe more of the reinforcement learning, deep learning, and evolved methods. Another consideration is thinking about the kind of data that the organization does have. And so you can see this Venn diagram that's going to be built here. If you have an idea for, let's say, the price prediction, you're building a price predictor app. To grab an example from Amanda White here. If you know that the inputs are going to be, location and date for this flight, and you know that you want that output to be a price, and you have some historical data to really build a model from, that's really fantastic, and you can work within a supervised space, so that intersection of inputs and outputs. If you have both inputs and outputs, you can work within supervised learning space or reinforcement learning. If you only have inputs, and you don't have any kind of historical outputs to kind of compare it to, then you can work within an unsupervised space. So an example here might be you want to explore the content on your, let's say, housing price platform that you just built. Or even better, the images on the housing platform that you built. So people are uploading images, but you're really curious to see what those images are. You can apply a clustering model and just simply see what happens whenever you apply the clustering model and feed those images, and see how it groups them into different sections. And so you don't necessarily know what to expect, but you're feeding it in, you know, those inputs. And so you're able to then analyze after the fact and see what came out of the analysis there. And then from there, build something maybe a little bit more advanced. Use that information to build something. In the output space, if you are interested in building your own, you know, like design, like the image, if you want to build your own image of what Jordy had just showed, those awesome graphics, and you want to build your own GAN to do so, general adversarial network, then you have an idea of what that output, you want that output to look like. And so you can build a GAN with that kind of cool output in mind. Like, I really want to be this really cool graphic. And so then you're able to work within a little bit more of a deep learning space. The final consideration is just to understand, like, if you have a full data set or a subset, if you're working in a space where you have some data but not all, semi-supervised might be a good path for you, and it will be more challenging. So semi-supervised, you can do you can try to take an existing model and transform it to your context as well, in the deep learning space, and generally operate within that space. Again, higher complexity, but I tend to come back to this whenever I'm thinking about an appropriate application. All right, so that concludes our conversation. We want to provide some additional resources here and give some shout outs and thank yous to everybody who helped us with this presentation. So we'll go ahead and take a look at our top takeaways, and we'll go into those resources. All right, so top takeaways here. Number 1, focus on impact, not complexity. You can deliver high value to your users without needing to build your own model. For case in point, the Karina project. Second, ensure those trade-offs and risks are highly transparent with your team. Think about desirability from user perspective, viability from business perspective, and feasibility from your engineering team. You want to ensure that those trade-offs are transparent at every level, and especially when you're operating at scale, when you're using an AI product, you want to ensure you're over communicating those trade-offs in your risk mitigation strategy. And then finally, I love this one. At Labs, we talk a lot about engaging your entire balance team. So working with product manager, your product designer, and your engineer every single day, and having those multidisciplinary conversations. Engage your entire team when you're building an AI product. It is not entirely a technical product. There is a huge element of UI here. So lean on your product design to manage that desirability aspect, product management to manage viability, and engineering to manage the feasibility. And with that, I'll turn it to Jordy to wrap us up with some resources and thanks.
Awesome. Thank you, Cassandra. So some links here. We've got the Private AI VMware Foundation's partnership with NVIDIA to deliver private enterprise AI. The Stanford AI Lab is a resource here as well. The Spring AI repo that I talked about, those were developed internally by Mark Pollack and Christian Zola. Their links are also here as well. The suggested foundational AI learning is a really terrific course that we took a look at on Coursera just to get some high-level understanding, common thread terminology, and technical growth there. And the case study client link, obviously, the Karina.org, if you want to check them out. I'd also like to give a shout out to the VMware Navigator team that is still working this in process. We're still doing that section, I think, today and tomorrow, so we'll wrap up tomorrow. Lots going on here, lots of folks involved, including some internal resources that weren't core to the team, but were definitely core to our understanding of how to navigate this space with Karina. And additional select thanks here to some other VMware folks, Amanda White, Evan Prowse, Kevin Clark, for supporting this presentation and feedback while we were putting it together.
Wonderful. I want to give one more shout out too. Amanda White has published a data science playbook. Find her on LinkedIn, check out that playbook, and check out our talk from June when you want to go into more product management for AI. And with that, I'll hand it to you, AJ. I know you have some questions ready for us.
Yes, we do. We do got several questions that we got here for you guys, but some of the links that you guys have seen there are available in the attachments tab. I think a few of them were missing, so we can make sure to add them so you guys receive them in the post-event email. And then in that list, there were some friends of the program, some folks that we've had on this webinar program as well. So special hello. Some of you guys are watching. Amanda White, I think Nick Kuhn was on there as well. So I thank you guys for supporting this project, the Karina project, and supporting the webinar program. So before we get into the questions, again, I want to say thank you to Evan, who's been in the background helping us facilitate some of these questions coming in from the audience members and helping set up this presentation. And then thank you to Cassandra and Jordy. Okay, now we do have a few questions, so let's see. Let's start with this one. Can you expand on the concept of ML ops, and are there any needs that stand out compared to typical software delivery?
I'm happy to take it, but Jordy, I know you might be able to offer a good perspective on it.
I'm going to defer to you, and I'll hop on if I can.
Okay, got it.
Yeah.
To my understanding, MLOps is similar to DevOps in that it describes a developer operation process. And so when you think of MLOps, you want to think about the ways in which the team is going to deliver value. So that can often be the process, it can be the principles that you're using as a team, and it can be multidisciplinary. So I've seen some teams where it's an engineering team that's building the model. I've seen teams where, like in the Korean example, I've seen other teams where it's engineers with data scientists. I've seen other teams where it's engineers, data scientists, and operations folks who are helping analyze the output of the model. It just depends on, I think, the complexity of the project, potential risks at hand, and the amount of oversight that the team has decided is appropriate for the model. Whatever a team does, I would just highly recommend externalize that conversation, be very explicit about the intentions and the way that you're going to be working.
Thanks, Cassandra. Jordy, I think this question might be for you. Do you have any suggestions as to how to convince the business that AI ML features are viable in products today?
Yeah, it's a great question. I think Karina is a great use case for that, answering that question. That's essentially what they did. What we did with them was explore that. We identified, I think, so what I would advise is doing something similar. Identify a couple of problem areas that you're trying to solve. Take a look at what AI, ML, and large language models are actively solving now. You can innovate even further and come up with a different use case, but like just to initially align with what you're trying to solve, does AI, ML currently potentially solve that problem? And then put together a test case for whether or not that seems like viable in the long run. And to Cassandra's point, absolutely bring in as many people, as many stakeholders to this that you can, because it really is not a technical problem. It's an end user problem. It's a product design problem. And while we didn't get to it in Karina's engagement, we absolutely had Karina and VMware designers working on UX and UI implications that we were uncovering by prompting. If you've ever played with, I think Adobe Firefly has a number of options that you can basically stuff the prompt in a very intuitive way, where you can pick different filters. That's a UI UX design choice to make prompting the model easier for visual learners. So who's your user base? Who are you trying to solve this problem for is a very important thing to consider when we're sorting out whether or not this will solve the problem for you. So I would highly recommend that.
Jordy, another question here from the audience. You mentioned that naming the AI is an ethical risk. Can you expand on why that is?
Sure. I can't quote her directly, but I thought the points that Clara was making, the ethicists that we talked to, were really interesting. So if you're in a vulnerable state and you're looking for answers, and it sounds like there's a person at the other end of this, there's a certain amount of empathy that comes from, I've connected with someone and they have my best interest. And if it turns out to be an AI that's hallucinating answers at you, you're going to trust that, even though it may lead you down a path that doesn't get you the care that you need. And so at that point, the organization that's delivered you that service is kind of ethically, morally bound to be responsible for that potentially. And so I think the idea was to be as transparent as possible with the end users, that we're using new technology. The technology is being leveraged to benefit you. And if it's not, please let us know. And also don't expect more from it than what it can actually deliver. I think there's a tendency to give AI and LLMs a whole lot more power, isn't the word, but influence potentially, right? Power and influence. And I think there's just ethical concerns about being hesitant about that, especially when it deals with personal information in healthcare.
Thank you very much. One other one here. What makes an AI capability or method more complex, and how does that change how you design it and the type of team makeup you need?
I can take that one. So I think you always want to start with user-centered design, understand what are the user needs, and then from there, develop those potential solutions, prioritize given impact and effort. I would highly recommend always starting small, finding that MVP, the minimum viable product, to really deliver that value. And so whenever you're then going into a technical design conversation, you want to find how you might meet those needs with the minimum complexity of the technical design. And so from there, when you're thinking about building a model and thinking about what makes a model complex, what makes a method complex, it's simply the effort required, and the layers of in the technical tool chain, I could almost imagine, that's required. But if you have a supervised method, a lot of times it's a simple regression model that you can actually end up doing in Excel. And so supervised methods and regression can be done by data scientists. It can be done by an analyst. For some models, everything is relative. But if you're moving into more unsupervised spaces and you're talking about clustering methods, those are more advanced algorithms that require beyond simple understanding of statistics, but require actual computer science. And if you move into deep learning, so you're then building layers of neural networks, you're going to need to have quite a bit of comfort, not only with basic computer science, but also feature engineering, and comfort with understanding that sometimes when you're building out those models, those features get abstract and no longer explainable, and no longer rooted in what we see as metadata. Does that answer the question, AJ?
I think it does. If you guys have any other comments regarding that response, you can send it over to the questions tab and we can respond to that. But it does sound good to me. And I think it has been quite the journey, Jordy and Cassandra, and I think we have one more question left. You guys ready? All right, this last question here is, do you have any tips for testing when a proposed feature includes a natural language output?
Should I take that one, Cassandra?
Sure. Okay. Oh, that's a fun one. I love that question. So I think that when you're testing, you always want to have a comprehensive approach between a qualitative and a quantitative approach. So if you have a model that's going to be, generating content, or grouping content or making sense of some kind of natural language. I prefer to start with a quantitative approach and just visualize the distribution of the data. That can be a bell chart, that can be a clustering kind of chart, but you want to get a sense of the size, the scope, and the frequency of different trends. At that point, you want to start identifying meaningful trends and then get into the qualitative space. Pick a sample that represents that trend well and look at it. Work with the team to really look at it and understand if that is a good, if that's an intended output. I would just recommend in this space that there's no perfect way to approach this. It's going to feel maybe a little bit, maybe potentially scary at times. And I think to work within this space, you have to be comfortable with a little bit of that risk. You're going to have to work within spaces where there are going to be false positives and false negatives. And those are active trade-offs you must absolutely communicate and write down and make transparent for everybody involved.
Thank you, Cassandra. Thank you, Jordy. Looks like those are all the questions that we have today. If anyone has any last-minute questions, submit them now and we can answer them here. Or if we don't get time to answer them, if you submit the questions after we end the presentation, we'll respond via email. Or maybe we'll have to bring Jordy and Cassandra back for another session to help answer those questions live. But doesn't look like any questions have come in. Team, I'd like to give you guys the floor if there are any closing thoughts, or folks can reach out to you or see what's coming up next.
Yeah, thank you, AJ. Folks are welcome to reach out to me on LinkedIn. I'm just at Cassandra Jaime, and you should find me under Cassandra Jaime VMware.
Yeah, thank you, everyone. You can find me at Jordy Jensen at LinkedIn as well. Just reach out. And thank you to the Karina team as well. These last three weeks have been a lot of fun, honestly, and I'm excited to see where they take the discoveries that we worked through these last 3 weeks.
Excellent. Yeah, another just thing to point out is we're getting the latest and greatest live with Karina. So thank you for sharing that with us and sharing with the audience. So again, thank you, Cassandra. Thank you, Jordy. Thank you, Evan, for helping us out here in the background for setting up this event. And thanks to all of you guys for joining us. This event has been recorded and will be available on demand shortly after the end of the presentation. There are some attachments, relevant attachments in the attachment section. I think they lead to some blogs, some older webinars, some recorded webinars that we have hosted in the past. And it will include also all the links that Jordan mentioned in the previous slide, or the slide that you see here right on your screen. So thank you guys again. We hope to see you guys at our next event. Have a great week, everybody. Bye all.
Thanks all.